Today we're going to discuss the last form of a linear equation. This is called a standard form of a line. Sometimes it's called a general form. And the third name that you might have for it is what's called the intercept form. If you guys would go to the back of your worksheet, I'm going to just give you some rules about standard form, and then I'll show you how we draw and we work through some problems. So if you'll flip your page over, and let me just give you the standard form of a line, and I'll kind of explain what all these A, B, C's are. So there's some rules for A, B, and C. A, B, and C must be integers. What are integers? Positive or negative whole numbers. And then there's a special rule that A has to be positive. So when we're doing these standard forms, keep these rules in mind, and if they don't apply to these two rules, then you're not really in standard form. Okay, so let's go back and look at problem number 1. I'll show you how we graph in standard form. If you look at problem number 1, A is equal to a 1, B is equal to a 3, and C is equal to a 3. And we would say that these are integers. A is positive. In number 2, A would be a 4, B would be a negative 5, C would be a negative 25. They are all integers, whole numbers, and in number 2, you can see A is positive. So this is sometimes called the intercept form because we can find the intercepts. What are the intercepts? We have two intercepts. When x is equal to 0, that will give us our y-intercept. And when y is equal to 0, that will give us our x-intercept. So when we're looking at a graph, let's do this first example as far as if I plug in x equal to 0, this term will go away. So just by looking at this, we should be able to see what y will equal in order to make this equation true. So if I say 3 times what will be a 3, hopefully we can answer a 1. So if I were to graph the y-intercept, I would graph the point 0, 1. If I want to find the x-intercept, I'm going to make y equal to 0. So that means if I plug in a y equal to 0 here, this term will become 0. And what can x be in order to make this equation true? In other words, x equal 3, what does x have to be? X has to be a 3. So how do I graph the point 30? I graph the point 30. I graph in my line, and I'm done with graphing in standard form. So let's try number 2. Number 2, I have the same idea. So I want to find the y-intercept, and I want to find the x-intercept. So visually, we just cover up the x, because 4 times 0 is 0. And what value does y have to be in order that negative 5 times that value will be a negative 25? Hopefully you know that that's a negative 5. The x-intercept in this case is a little trickier because if I put y equal to 0, this will go away. And if I say to myself, 4 times what is exactly negative 25, there isn't a real good value for that. So it's going to be a decimal value. So how do I graph that? 4 times what value equals a negative 25? Let's solve for x. If I divide both sides by 4, I get x equals negative 6.25. So it's not a whole number. That's all right. That just tells us where it's going to cross the x-axis. So at negative 6, here's negative 7. How do I graph negative 6.25? Just go a little on the negative 6.25. If I graph the point 0, negative 5, connect those 2 points, and we'll have the line. Now again, this is a little different than what we're used to, but we don't have to do any manipulating. All we have to do is cover up the one variable, solve for x, cover up the other variable, solve for y, graph those 2 points, and sketch in your line. So I'll ask you to do a couple of those, and then we'll continue on with our notes.